guys, we're going to get started soon. Okay. All right. Welcome to Program 12. How many people here have been to a program event before? Many of you. Okay, cool. Awesome. Well, if this is your first one, welcome. Program is a software workshop series where we kind of explore new frontier technology together as a community. The way these events work is we start with a workshop lead that walks through a specific technology, open source project, creative tool, developer tool, something that's emerging that we're finding interesting and we think that we should be learning together. Not just sitting in front of YouTube and watching tutorials, but learning together as a community. And the majority, once that workshop lead typically goes anywhere between like 15 to 20 to 30 minutes. But the majority of this evening is actually kind of builder's time, right? So we hope that many of you have brought your laptops with you, that you are excited about this topic, and that you're ready to build something. So we will have a portion of this evening where we'll just do builder's time. It'll be open. And then if we have enough demos at the end of it, we'll also squeeze in some time for demos. But today's session before I introduce our workshop lead, I just wanted to say thank you, first of all, to New Systems. Is this anyone's first time at New Stadium? Okay, awesome, welcome. This is an incredible space, an incredible community space. It's been really important for the city and especially for us doing these program events, so thank you to New Systems. And today's program event is about reinforcement learning. And reinforcement learning is this concept that the term isn't new, but has been, had like kind of a renewed wave of interest recently, obviously with everything that's happening. And there's been a lot of real, interesting advancements in the space. Our workshop lead for today is Logan Grasby. Logan is the founder of a startup called EVERYWHERE.DEV. And has been in also the Cloudflare machine learning engineering team. Did I get that right? Yeah.
Machine learning engineer Cloudflare.
Okay, yeah. And is sort of kind of an expert on this topic. So I'm really, really excited to introduce Logan and to talk about reinforcement learning today. And if you have any questions, please save them for do you want to do questions at the end, or do you want to?
Yeah, we can do questions if you think we can play by ear maybe if we have time.
Yeah, let's go through the workshop. It's about 20 minutes to half an hour, and then we can do Q&A, and then we'll do builder's time after that. If we have time for demos today, we will do demos. If not, then we'll just have to shorten that session. One just note in terms of housekeeping, bathrooms are downstairs. We will also be ordering pizza, and that should arrive in about an hour or so, around the builder's time. We're gonna have some pizza as well. So anyways, with that, I just wanted to say thank you again to Logan for doing this, and thank you everyone for coming here today. All right, there you go. I need you to put this thing on too.
Yeah, I'll put this on too.
Thank you.
So I'm really mic'd up. And we'll see if I can get this on in a not awkward way in front of all you guys. No, it's definitely becoming awkward. Oh, there we go. Okay. Hopefully you can hear me.
Yeah.
Cool. Okay. So we're talking about training large language models with reinforcement learning. Specifically, we're actually talking about fine-tuning large language models. I'll do a quick intro. The product that I've been working on has a flashy landing page, but it's actually pretty boring. It's a product to run code effectively, and very focused on some of these new use cases, like the ones we'll talk about today, where you need a lot of data, a lot of replication of the work that you're doing. Before that, I was working at Cloudflare as machine learning engineer, primarily working on their product called Workers AI, which is mainly LLM and image generation. So it was very interesting because Cloudflare has global data centers, the kinds of problems that you have to deal with, especially in kind of like this new use case. Super interesting to see that kind of grow as, really going from the first like Llama models to this just explosion in new tasks and use cases that people have for AI. It was Cloudflare's first time deploying GPUs in their data centers. Before that, I worked on a product that helped e-commerce brands use AI to sell products on their store. So it would create a widget that would interact with a page. So for example, if you were selling any kind of product, you could ask your chatbot to bundle products together for you, and it would actually generate code, and then that code would be executed in the browser to interact with the page. But this was back, like this was GPT 3.5, the API that was powering this. And the original version was with DaVinci, but that basically didn't work. But anyway, so I've been working on these kinds of agent problems for at least as long as it's been possible with large language models. And so very, very interested in this space. But I also don't think that agents are very interesting anymore. And that is the main, hopefully I'll convince you of that. And that there's, that training models is much more interesting and worthwhile, especially if you're building a business. Raise your hand if you're working on a product or a business that is using agents in some way today. Okay, cool. So yeah, basically what I want to get out of this is why should you care about training models, specifically fine-tuning models, and specifically using reinforcement learning. What are some techniques, or how these techniques work, how you can apply them very practically, and some of the libraries that we'll then hopefully use after the fact to actually try this out for yourself. You might have seen this MIT report that 95% of generative AI pilots are failing. So that's not good for us that are, those of us who are working on AI agents. And it's interesting, I mean, I'm sure there's lots of analysis in this report on why that is and what have you. One thing that I think is interesting personally is to consider there are products that are working very well. There are companies that are doing incredible, companies that are profitable, at least on their, if they weren't training billion-dollar models at the same time, they would be profitable. And so for myself, I can say I use AI all the time. I spend more on AI than I do any other, like probably second to rent at this point. But yet none of that spend is with products. It's all direct API usage. And so that it kind of begs the question of, well, why do we jump to agents as a solution? I think the answer is probably pretty obvious, and it's that we know how to program. And so we can program agents because that's just another API that we can use in our program. And we already kind of know how to design these things. But models, that's a whole new world. And so there's, I think, a resistance to actually just like, learn from scratch this whole new topic where you're a complete beginner if you're coming from the perspective of a programmer. But this is very clearly, in my opinion, where these companies that are creating value are able to do so. And you can do that as a startup, and perhaps only more recently, but that is really where you can create meaningful value. Here's just one example. This is from a Chinese company that's deployed large language models at a huge scale. It's the company I will probably mispronounce. It's called Bao, I believe. But it's an e-commerce company. They wrote a research paper about how they did this. long story short, they're using a model they trained themselves to look at purchase history and a bunch of events, and then to make very powerful recommendations on what customers should do next. So very similar to that, the product that I was working on. And I realize now that there's no way that I compete with this. I had not known that at the time. I thought I was a genius. But in reality, they are, this approach is so clearly so much more powerful than trying to wrap an API. Because they're using data that no one else has access to. It's specific to their business, and it compounds over time. As you collect more of that data from your users, if you have a way to continue training, and that's what we're going to look at today, if you have a way to continue training your models on this data, you're creating this compounding effect where over time you have a more and more valuable model that's specific to your business. It isn't useful for anybody else, but it's useful for your business. And it does that incredibly well in a way that no foundation model from a big lab is going to compete with, because it's so specific to your use case. So now we're getting into specifically what we're talking about today. So just at a very high level, when you talk about training large language models, there's kind of two stages. It's actually an overgeneralization to say that there are two stages, but that's going to be the theme on the kind of algorithm side, because we're going to focus mostly on very practical use cases and skills here. We've kind of gone through a bit of a journey where we've kind of gone from the main focus being supervised fine-tuning, the first box there on the post-training side. RLHF, or reinforcement learning from human feedback, it was made popular by OpenAI. And now what we're talking about today is reinforcement learning from verifiable rewards. This isn't to say that this is some kind of sequence of things that you do, or that one of these, or that supervised fine-tuning is now obsolete. It's just more to say that the focus of how we're pushing the boundaries of what's possible, and also what is most useful for kind of if you're training without millions of dollars in compute, this stage, reinforcement learning from verifiable rewards, is specifically interesting to us. The other word is GPU, or the other phrase is GPU poor. Those of us who are interested. So to kind of put, I think this is a way that I found this to be easiest to explain, is to look at some simplified examples of what a data set looks like for each task, or each approach. So in supervised fine-tuning, we have our prompt and we have our response or completion. We're essentially training the model on, if you see this, then do this. It is kind of the simplest way to explain it. And your data, you need to prepare a data set in order to train a model this way that looks something like this. And this is a lot of work, because if you're starting from scratch, you know what you want to do, but you don't have that data set. Well, either you're going to sit there and type it out yourself. Now, you might say, well, I already have GPT-5, it can generate the data set for me. Well, yes, it's nice that you have that now, but realistically, this is going to be either a very expensive and a lot of effort in order to always take this approach. Reinforcement learning from human feedback, is kind of the first way that we kind of saw that, there are some kind of alternatives that are very scalable, very interesting, that will potentially, still very expensive because you have the human part. But in this case, something very different. We have multiple examples of a response, so we still have that prompt and completion, but you can see there's multiple candidates. And we are actually training two models here that you'll see later. And our final output, or our final kind of data set, you'll notice is missing the completion. That's because we are first training the reward model. The reward model is effectively telling us later, when we see this second row, that whether or not that response that we're going to see, which again you can see we don't have the response here, That's because we're going to generate it with the model. And then we'll decide whether that response is kind of on policy or not. And we're going to update the model that we're training accordingly and kind of do this in real time. So we're generating the response, asking the reward model what it thinks about it, and we're using this algorithmically to train our model. So that's kind of to get up to speed to where we are today and what we're kind of most interested in now, which is reinforcement learning from verifiable rewards. The easiest way to think about this is not this image by far. The easiest way to think about this is that we can instead just take, before we had this reward model, we're going to take that away, and we're going to replace the reward model with some way of programmatically identifying whether that generation is something that we like or something we don't like, is something we want the model to do or something we don't want the model to do. So in this previous example, we had this human scoring that allowed us to train a completely separate model that is saying in the future when our model generates responses during a training run, are those responses something we want or not? We replace that in this case with some kind of programmatic way that we're going to look at. And the reason this is interesting is because you remove the human part. So before we had reinforcement learning from human feedback, and we don't from a kind of just amount of work stance, this is significantly easier to get rid of the human. And now if we can verify programmatically whether our model is doing something useful or not, well, that's a lot easier for us. And this is a big advancement because it means that as someone who doesn't have billions of dollars to blow on training models, this becomes very interesting, and, because now we can do it for a much lower cost. So what does it mean? What does programmatically even mean? Here's a very simple example. We're training the model to think. Specifically, we want it to output these thinking tags. And we're going to return from this function a reward. And this is going to be the majority of the work. The majority of what you work on today will for sure be this. And we're essentially trying to say, well, we want our model to output these thinking tags, so we're going to reward it for that. We're also, if we only reward it for that, though, it might decide, okay, well, I only need to output these thinking tags and nothing else. So we also want to reward it for there being content in the thinking tags. And so this actually works. This exact reward function can be used to train a model that doesn't already show any kind of thinking process. You can use this exact reward function today, plug it into one of the libraries that I'll show you, run it, and you would train the model to do that. And now it would, in theory, spend more time reasoning about the problem. Now, the interesting part about that is that you didn't purposefully train it to be better at reasoning, but the outcome by forcing it to, kind of to do this, and probably you would introduce other rewards, but you kind of gain these capabilities almost in addition to the exact literal outputs that you're trying to reward. The other thing that happens as we improve these algorithms is we reduce the amount of GPU RAM that is required. And this is very good for us because we don't have a lot of money. And so now this is like, as these algorithms, specifically some of the ones we're going to talk about, GRPO, and there's like GRPO plus, there's GRPO 0, there's like GRPO at this point is almost old news because people are, the specific algorithm doesn't matter. It's specifically this point that you can programmatically verify whether the model did what you wanted it to do or not. This is the only point that matters. All of the work you're going to do is in the development of these reward functions or however you define the reward. The specific algorithm is honestly not that important because you're going to pick whatever is working best at the time. It's going to be different next week. probably. So this is, we looked at the two examples of data sets previously, and now we get to where we are today, much easier. Now, all we need are prompts. We don't need, so now this is way easier for us to start to implement, because if we have working reward functions that actually let our model know whether or not it's doing something useful, then we simply can provide it a data set of prompts. If we have one that, for example, has a bunch of math questions, well, we can write a reward function that actually attempts to parse the model's output, and then we can actually mathematically verify, did it, write an equation that actually makes sense, and then we can, develop a reward function that trains our model to be better at math. These kinds of examples are relatively straightforward to implement, and you can, I'd say fairly easily as an example that you can try today. These are great. These are great, very easy tasks. So why do we care about this? And it's because, to reiterate what I was saying before, you have all of these products today that are doing this, that are doing some version of this. We don't know exactly what, but these products that are run by these large AI labs are doing something that all of these startups, in most cases, are not, which is that they're able to take these arbitrary inputs that are your prompts, that you're writing, that are on a use case they never thought about. But they're able to improve, regardless, they're able to improve their models continuously. And it is this compounding effect where the more you use their products, the more their products are going to get better. They're able to update them potentially close to real time. Real time is maybe an exaggeration, but we are on our way there to really seeing models update in real time. And if your startup isn't taking advantage of this, or your product isn't taking advantage of this, or your business just isn't, you're really, there's just a massive amount of value being left on the table by not taking advantage of this specific fact that you can take these without a massive data set ahead of time. You can take only what your users are doing, and you can turn that into results. And so this is the thing I think to take away from this, is that it's not obvious at all. It's not obvious to try this, but if you can figure out a way like that, that paper that I showed you earlier, where they're creating a recommendation engine that's driven by a large language model, this is deployed now at a massive scale in their case, where they're seeing, higher conversion rates. So that's translating to millions of dollars in revenue. And it's something that if you were to compare to, I don't know, their closest competitor who's not doing that, I mean, it's kind of a night and day difference, because that model gets better every day, whereas their recommendation engine doesn't. There's so much to say about, obviously it's a very broad topic, and I think before getting into this, I wanted to kind of talk a little bit about the actual mechanics of what it looks like to train or fine-tune a model this way and what you might expect. So you can imagine that you're providing your model these rewards, and you are hoping that it's going to output something that is going to be rewardable, but it also might not. And so there's kind of two factors to think about as you're trying this yourself. One is that because the model will see all kinds of data, that there's a chance that it will reward, it will eventually, after a long time, there'll be no reward, and then suddenly, by chance, it will do something useful. But that's kind of expected. That's not, you actually do have to be patient, which is not really ideal in a setting where you're trying to iterate quickly. But in reality, you do kind of, you're almost hoping that the model is going to randomly do something rewardable, and it's a mistake to just say, oh, I'm looking at the logs, and kind of 2 iterations in, and you're not seeing any rewards. And so it would be a mistake to kind of think that it's so easy. In fact, what we hear from larger labs is they even will discard entire training runs because they don't initialize properly. You don't ever start to see rewards, and so it's kind of interesting to think about how much wasted compute there is there. But the more specific your task is, the more you can probably reduce the likelihood of, or reduce the amount of time you have to waste doing that. And so this example I have up here is, like, you might kind of wonder, well, what is, like, how do I approach this problem in reality? And in reality, we can see that you don't just get to discard all the other kind of fine-tuning methods. That really supervised fine-tuning, where you have explicit prompt and completion, is very useful still. In fact, it is a way that I would probably recommend to initialize your model, where you can kind of feed it some examples of high-quality outputs, and then you can kind of increase its understanding and ability on that task with reinforcement learning later, and you can scale up compute on that much more than you would be willing to potentially, because it would be so much time to develop that supervised fine-tuning data set for your task. Remember that what we're concerned with here is, like, how do we do this practically? How do we do this? How do we personally do this with very few resources? I think that looks very different than what you would do as a larger lab. So some of the libraries that we'll use, or that I'll recommend anyway, the main ones that are, I think, actually of interest are Hugging Face's TRL and a library called Veral, which is volcano something reinforcement learning, but it's by ByteDance. And there's tons of libraries out there, but most of them are, Unslosh is a great library as well, but most of them are wrappers around TRL or Veral. The rest of these that I have in the training section are actually, Unslosh gets a lot of credit for writing custom kernels, but like SearchR1 is a super interesting implementation that is very easy to get started with. The setup might be time consuming. Same with R0, RLLM. These are all examples where there's a kind of specific task, a specific environment that has been set up for you that is very easy for you to get started doing something specific. So either it's making a model, or training a model to be very good at search, to train a model to be very good at code generation. The RLM library has a great example of that. All of these things are, kind of, I think, get into the last point, which is where we are today is really focused on this idea of environments. And the idea of an environment is almost kind of, not real, in the sense that models only output text. There's no environment. We're not adding an environment to the model or something. The environment is just like a term to say we have some kind of program around the model that is always going to exist, that it can always interact with. And it can interact with it by, we're going to, like we do with tool calling, it outputs a request to use a tool, and then we programmatically feed back the response from that tool. The idea of there being environments is to say, just like with these like SearchR1 example, what these are doing is just building something for you that you can easily use, that you can plug in your own data set, that is specifically, that is for a specific task. That'll help you train for a specific task. And the more of these that we build, the more that we'll be able to kind of easily train models for specific tasks, because it's hard to develop these rewards, but if somebody's already built them for you, now it's much easier to train on your data for that task. And so that's kind of the next really exciting thing is the more open source contribution there is to these environments, the more you'll be able to easily off the shelf grab a tool that's ready to go that can be launched. So then maybe the last thing I'll say on this is you can kind of look at what are the steps that you might take in order to go from trying this for the first time to training on multiple GPU clusters or multiple servers equipped with many GPUs or a GPU node. I think starting with what I'll show you today is Unslosh, which has some great libraries that you can run for free, examples you can run for free. I think moving from there to TRL is a really good approach because all of the most recent meaningful developments are usually quickly integrated because it's such a popular library. And then with something like Veryl, you have tools built in that really scale across multiple GPUs. So once you've found something that works very well and you think I might want to see like what kind of performance do I get at scale, and I'm willing to put some money behind that, then the tools that you have there are much more much more appropriate for larger scale training runs. I'm happy to talk about this more if anybody is interested in specifically some of the nuances around setting up kind of larger training runs with these libraries. And then the last thing I'll leave you with is, this is from 2 hours ago. Andrej Karpathy, one of the very famous AI researcher, posted this on X. I'm bearish on reinforcement learning specifically. I think that reward functions are super sus. What he's saying here is not that they don't work, but that as a kind of like, how do we get to AGI? This probably isn't it. And like, it's probably true. There's probably going to be something next month. But I think that something that's meaningfully changed, that is a consistent theme, is like, if we can verify, if you can train a model in a way that doesn't require require human labeled data, it doesn't require tons of effort on creating data sets, then that's really how you make this approachable to teams that aren't foundation model labs. So regardless, like, you're going to have to keep up to date as things progress. But I think these libraries that we looked at are, there's a lot of people who are very inclined with making sure that people who use their libraries are kind of using the most up-to-date tools. So I think you're actually in good hands to sticking with popular libraries that have that incentive. It's maybe like less popular libraries that probably, something new will come along and then they might get abandoned. But yeah, so I think I'm probably like way over. So we're okay. So I'll show you quickly. Unslosh has some great examples and that you can modify yourself and that you can run for free. And so I would recommend checking out these notebooks. A lot of these are going to be very eerily similar to TRL, and that's because a lot of them, actually this is one of the notebooks here, and that's because there's a lot of the it's been adapted from TRL. But in this example, we take what's called a base model. So it's a model that hasn't been fine-tuned to answer questions yet. So it's kind of the model just after the pre-training stage that we looked at. And if you know how we have like these system, this might be things you guys already know, but we have system prompts, and we kind of take this as a thing that models like just maybe inherently do, but they don't. We have to train them on these chat templates, and that's what this is here. So in this example that you can run on a free Google Colab, you actually train the model on this chat template, and then you train it on essentially on reasoning ability. And in this case, they start with supervised fine-tuning, and then after the supervised fine-tuning step finishes, then they train the model to kind of reason on, I believe it's a math problem. And the final kind of implementation of this is really this training class here. And our reward functions are passed. And really, there's like, you're going to see, for example, this like config might look super scary, but as you are thinking about how do I modify this for my task, like these things are not what you need to focus on. Like, take whatever is your library of choice is recommending as through their examples as kind of a configuration, and just go with it. And what you need to focus on, which is it's still very hard, is developing these rewards. And I think at a minimum, running these and seeing that, yeah, like if you can do this on a free, you can also like apparently run it on a MacBook, like if you have enough memory. But even seeing that you can run these yourself, I think is very eye-opening. But then developing your own reward function, you can actually is not that scary, and it's really, I think you'll very quickly start to like have that aha moment once you do that. One thing I really recommend is in the actual reward, you should print the or like log in whatever way you want what the model is generating, and the reward that is selected by your function, and log that on every time the reward is invoked, because you'll very quickly start to kind of get what's happening. You'll see almost the model being trained in real time. Like it'll start to improve or it'll go terribly wrong. But either way, you'll like see the model, the output of the model change as it's being trained in real time. So that is one thing I'd recommend. If you decide to start to look at how you might scale this up farther, you want to, in all these cases, we're using some quantization and like techniques to make the model training more efficient, but potentially at the cost of accuracy. In the actual TRL library, there are examples that actually, I'm at the, like, this is actually not an example. This is the, but there are examples that, okay, this is a great example. That you could actually scale from the exact, a single file like this. You could scale this through a bit of configuration to multiple GPUs or to multiple GPU nodes. And actually, I think it's underappreciated that this is actually a very scalable library. And yeah, with just like a little bit of configuration, it can go a long way. And so that's where I'd recommend that you start. If you do feel like spending some money and really seeing what it's like to train at maybe a larger scale, I'd recommend trying out RunPod, which is a GPU provider, and I'm happy to give you some tips on doing that if you want to today. I think that's all, and I know we want to get started, so.
Yeah, does anyone, I guess my one question is, and if you don't mind, can I grab that mic?
Yeah.
The mic for if there's any questions on setup and stuff. But are there any examples so in these TRL examples, any that you recommend specifically that you think are great for someone that has never done this before?
Yeah,
right?
Any of the, and I did have this open on the wrong example, but any of the Unslosh examples are great. Like this is, I'd say, you know, the next thing to do as you work on this in your own time is for, and obviously today, is any of these notebooks you can instantly run for free on Google Colab. They also have, you can run them for free on Kaggle. There's examples that run that you can run on Kaggle as well.
So you can literally just go open the notepad. You can play with these parameters. You can see kind of what that feels like. So if you haven't, I mean, this I'm speaking for myself here, is like if you've never actually done one of these reinforcement learning runs for this in this specific context, like, or one of these training runs for a like actually training your own model per se, this is like a useful starting point.
Yeah.
Does anyone have any questions? Yeah. Okay.
First for local, what size model? Like, let's say you have 32 gigs of RAM. Like, what size model is reasonable to attempt to do some RL fine tuning?
You need a lot more memory to train than you do to.
Okay, so 32 is not enough.
No, you definitely can. You can definitely train. You know, when 0.6. There's a Quen 3 0.6 billion parameter model, which is more recent development, is like surprisingly good for such a small model. That probably with the quantization techniques that Unslosh implements, you probably can do that. But it also is the case that like you might have to, you know, as you do training, yeah, you might need more. You might be able to use the model on your MacBook for sure, or whatever computer. The training you might decide to, you know, take somewhere else.
Mm.
But actually, I shouldn't say that because I'm continuously surprised at how well training on MacBooks works specifically. It's actually specifically MacBooks that work very well, like the M series. So they have examples, and Unslosh does. So I would try those out. I mean, let me know if it works. Like I assume that you can, but you know.
What was the name of the model that you just recommended? It's 0.6.
Oh, it's Quen 3, 0.6 billion parameter.
Didn't know they had that.
There's a whole Quen 3 series, and it goes from like 0.6 to then they get into like mixture of experts. But yeah, I'd actually say for models to start with that are worth today training, for sure the Quen 3 0.6 and Quen 3 4 billion parameter are both just high quality to start with and will adapt very quickly to in a useful way. And another thing is that if you can demonstrate a reward is useful in a smaller model, then it becomes way more likely that it's worth scaling up. Like you kind of want to do some cheap experiments early, and then you can decide like, oh, okay, I want to see if this really works, and then you can, you know, like decide to spend a little money to try and run it on larger GPUs. But
Cool. Just one more question. So on the reward function side, the examples that you showed were like math problems, like very specific numerical outputs. But if you have a data set that's like, I don't know, like customer service or something, where the model output could be like any sort of wording of the same, like it's more of like a text output, like could be any type of wording. What are strategies to set up your reward functions in a way that you can evaluate those outputs?
yeah, that's a great question. I actually meant to include that and totally forgot, to be honest. You can define, effectively you can use another model. And you could actually use the same model. And you can do things like, you have your data set of just prompts, and you can generate ahead of time a rubric or a checklist, you could call it. Basically, you're trying to, you come up with a prompt. It's like a very simple, Python script that is going to say, okay, for every prompt in this data set, you should ask this model, and you're probably not going to do this with GPT-5, but do this with something that's very cheap or running locally. And you're going to say, come up with like what are 3 things that would that you should evaluate for that I can score that would make a response high quality. And then later, you can use in your reward function, you can ask a model, hey, here are the here are the things that are scorable, and they could be specific to each prompt. So each line of your data set could have its own, either the entire data set could have its own own rubric, own checklist, or you can have every single prompt can have its own. This is like fairly easy to generate, honestly. And then you can, in your reward function, actually just score each of those. This is actually the easiest way to develop a reward function. And it's almost, I mean, you could kind of argue it's cheating because you're using a larger model that just happens to exist that's like better than your model. But I would also argue that to get started, this actually might be significantly less frustrating. So I'm not going to say you shouldn't do it. Like this, you probably should do it, to be honest. Does that answer your question? Yeah. Does that make sense, the checklist thing? Or is that, okay.
Can you push boundaries with the reward models? Because if, like in this case, we would use a better model to evaluate and get rewards, but at some point we would want to train a better model than Claude for Opus or GPT-5. And if they're trying to, train that, like you mentioned that in the consumer chat apps, they're taking our prompts and doing RL. Do we have insights on what they're doing for reward models there?
Yeah, so there's something really interesting here that at least from my perspective, I feel like is poorly understood, but I'm sure there's somebody who anyway. What is kind of an interesting question is like, does the model, is it like learning new things, or is it just like, are you bringing out things it already knows? And when you look at a model that is so large like Claude for Opus that it can write you an essay, it can write a program for you. What it's looking like is it's the case that these models know a lot more than we're able to get out of them, and that fine-tuning on a specific task brings out things that it already knows, and it gets much, much better. So that is to say, these models that are provided by these large labs are not trained for your task in that way. And that if you are able to bring out those kind of characteristics through this training process, that it is inevitable that your model will be significantly better. Not that Claude Opus couldn't be better. If they fine-tuned it on your task, it also would bring out those characteristics. It would kind of like, it knows things that it isn't able to generate in a way. But that fine-tuning on that specific task can start to, it might like look like new knowledge, but it may actually just be things that it already knows that now it's able to do in a much higher accuracy way. So to a great degree, I think that fact alone plays into your favor, that you certainly will be able, I mean, there's without a doubt, actually, you will be able to train models that are higher quality at a specific task than proprietary ones for that reason, and just simply because just the fact that biasing a model so aggressively towards a specific task will have that outcome, and then it might be terrible at everything else, but you don't care because you only care about that one task. But there's also the case that actually that actually is a good point, and it makes the case for these reward functions, because they're almost it's so grounded in reality. If it's accurate, if your reward function is really rewarding something that is that is what you want, it's in a way that is completely programmatically grounded in reality, in a way that asking a model, is this right, is not necessarily. And so there's almost like, a lot of value. There is a lot of value in that. There's a lot of value in that grounding that you can't get out of a larger model, if that makes sense.
I have a question. So the recent OpenAI open source release, GPT OSS, I think. Do you know whether or not that was trained very specifically? Like, is that a good example of a model that was like trained very specifically for I think it was like coding or agentic tasks specifically it was good at, but it was like terrible at everything else? Is that like an example of something like what you just mentioned around, like?
Are people saying it's terrible at everything else?
Well, maybe I'm misreading, but when that model first came out, yeah, some of the early reports were that it was like not great at a lot of the general tasks, but it was very good at coding.
I guess I haven't heard people, I mean, not that I'm sure there's validity to that because I imagine they are heavily focused on.
And maybe it was early reports, so like people weren't really.
Yeah, I mean, I guess I haven't heard people say that it's bad at specific things, but I guess one thing I could say is the smaller the model, you know, you're kind of going to start to see things that, you know, you can't just like have such breadth of understanding about the world in these smaller models. So you definitely lose ability that it's called, you call it catastrophic forgetting. You like, your model become like suddenly just not able to do a ton of other tasks. You like fine tune it and now it like doesn't know what clouds are. I mean, I don't know. But like, you know, so it would be complete speculation for me to say one way or the other, but at least I can say that phenomenon exists, and it's it's easier to see it in general in smaller models than it would be in a larger model. So if you really wanted your model to be very good at agentic code generation, I wouldn't be so surprised to see that it becomes worse at other things.
Any other questions? Okay, we'll do like maybe one or two more, and then we can start with others down here.
Sure.
Thanks for the talk. I'm curious about how do you deal with sparsity? Like if the model is just not getting enough rewards, like what do you do in those scenarios where it's constantly just getting a 0 reward instead of a 1 reward? And because RL, you kind of have to do a lot of rollouts to get to the signal. And so how are companies dealing with it? Does the model size matter in this case?
I mean, I think one thing that's perhaps not super obvious at first is that you do need to be patient. You kind of want to be okay with relying on the fact that because you're running through this data set that is hopefully really diverse, and you're kind of, you know, to some extent need to be okay with like accepting the fact that like hopefully randomly you're going to get a reward. Now that's like super annoying, especially when you're trying to run experiments like this. And so I would say you can, I think though realistically, get an idea of whether your reward function is like quality or not by perhaps biasing. You can, with a model that's previously instruction tuned, you could, you know, really focus on like under which circumstances that a model will be rewarded. So you can run like just, you know, be looking like one prompt at a time and develop an understanding of like, okay, maybe I won't know that this is necessarily, you know, how long I'm going to have to wait, but at least I can know that I've developed a high quality reward function. And then at that point, if you feel pretty good about that, then as long as your data set has is decently diverse, then you kind of have to just accept playing the waiting game. But it's also like, it's a bit of a game in the sense that this is like a good trade-off, because the alternative is very expensive and time-consuming of developing data sets manually. Another thing I should say is, and actually I'd really recommend this, is especially if your task is narrow, fine-tuning initially, or supervised fine-tuning, where you have a specific prompt and completion, is a great way to start. And that, in one of the examples that I just showed, the Unslosh examples that you can try, they do that. And this is a great way to quickly get a lot faster. I'll give you an example of something I tried to do that did not work. This is a web component library I really like, and I was like, okay, I want to train a model to a small model, this is Qwen 3, and I was like, okay, I wanted to train it to generate this. It's kind of a weird use case. This is actually large models don't do this very well. Even GPT-5 will often, if I ask it generate a whatever from the CSS doodle library, it'll usually just be invalid. And so I did things it's okay, make sure the tag is there. There's a reward for the tag. There's a reward for there being content within the tag. There was a reward for some of the specific keywords here. And I tried to do it without supervised fine-tuning first, and I wanted to see could I get there with just reward functions and no feedback from another LLM or anything. And it actually kind of worked, but it got really hard. It would figure out one specific example that worked, and then it would try to, no matter what the prompt was, it would everything would be very similar. Anyway, I think you could figure it out just with reward functions, but I probably just needed more time, and I wasn't being patient enough, and I really wanted to see results very quickly. So that's an example. I mean, I was gonna show this as an example, but it was didn't really work. The other thing I tried doing with this as an example of how creative you can get is I tried rendering it. So I rendered it, took a screenshot, and then I programmatically would do things okay, what are the colors in the image? And so I wasn't asking an LM what are the colors in the image. I was programmatically, trying to figure that out. And I got GPT-5 to generate these incredibly complex formulas that you would never write yourself, of trying to calculate how visually complex the image was, and develop rewards that way. Anyway, I got super into it. It was kind of a mess, but hopefully, I don't even know where I'm going with this. Hopefully that was useful.
Let's go to one more question, and then we can kick off. I have to give it to him. Sorry. Here you go.
Thanks. Going back to the three-step process by which they trained OpenR1, it was somewhat recursive. So they started with getting distilled reasoning data, and then supervised fine-tuning, and then they applied gRPO, the next step, and then the third step was combining both of them, right? So it was.
From this example that I gave.
Yeah. There was a three-step diagram there. Yeah, that's the one. Slide 17.
Oh.
Yeah.
Yeah. So, sort of. Your question is just.
It's so how do you know at each step that you've done enough and it's time to move on to the next step? Is there a certain marker in the model that tells you?
I should say that I wouldn't take this. This is a very advanced example. Or in fact, this is the most advanced example. The Hugging Face team is working on this project with the goal of replicating DeepSeek R1 in an open source way end to end so that anybody can replicate it. So it's very complex. I would not recommend trying to follow this process for a simple project. What I would say is that if you look, if I were to make a yeah, if you are trying to train your model to be, yeah, a lot of the time you'll see, especially, and actually going through this library, I would say they use TRL, and it's also a great, just it's such a huge training run that is done with this library that it is, I think, a good example of how scalable it is. But you will notice that in their reward functions in this library, that they have one for math, they have one for formatting, they have one for all these a bunch of different tasks, and that's because their data set is very diverse. They're trying to, it's not trying to be good at one thing, it's trying to be good at many things. I think the opportunity for people who are just getting into using these models is like find one thing that it can be good at. Because then you can apply the abilities of a large language model to a very specific task. I think the example of this kind of looking at purchase history, this kind of task where you're looking at purchase history and you're trying to come up with recommendations, and you're doing that in a much more intelligent way than you would have been able to before because you're using a large language model. And it only needs to do this. It doesn't need to do anything else. In this paper, they actually come to the same conclusion where they need to start with supervised fine-tuning, and then they need to move on to really get the model to have diverse capabilities to use GRPO or the whatever algorithm comes next, but really to develop rewards for did the generated recommendation match this history? That's another interesting example. Is like, how do you come up with a reward for something like this? Like, that would be a really interesting problem that once you figure out, now you can just throw data into it. That, I think, just to, and I know I'm rambling, but to underscore that point, I think that's the really important thing to realize is that once you do this work, then you can just throw data into this thing, and if you know that you're going to, you can kind of rely on the fact that the more user data that you're able to collect from your product, you can really just continue to throw that data into your model now that you know your reward functions work, or that however you're generating your rewards, you know that works. You can continue to improve on whatever that model is doing in your product. And so that's the really important thing that, yeah, so I know that wasn't, went a few different directions, but,
Sorry,
oh, I'm just wondering if we're,
I think yeah, we can start whenever.
were there any other burning questions?
So yeah, if you have any other questions, I mean, feel free to approach Logan. And yeah, for the rest of for the next hour or so, we're gonna do builder's time. So find a seat, find someone to work with. Go through these examples. It might be useful just to put up you had a bunch of browser windows for these ones, so for the Unslosh example and TRL examples, feel free to start playing around with them. I'm not sure if we're gonna get to demos today. Again, it just depends on how people are feeling on if there's something that you think is worth demoing. There's no pressure, but if you do have something to demo, by all means, please I'll go around in about half an hour or so, just ask folks how people are feeling with that. Pizza should be here in about 20 minutes or half an hour, actually it should be here way before that. Should be here in about 10 minutes. And yeah, that's it for the workshop. Thanks again, Logan.
Thank you.
And yeah, enjoy the rest of the evening.
Unslosh is a really good starting point. Yeah. Are there any sort of communities you've found where people people are sharing things that they have tried and hasn't worked, hasn't worked, that you generally try to go into? Like I know Unslosh Discord, but there isn't a lot of info there.
I would say,
Oh, hey, how are you?
the reality.
Long time no see. Yeah.
Have you been in town? Or?
No.
Okay,
I was in.
this is actually the best. Ask the best advice I can give on that.
Yeah.
Is,
Not really. I was doing the whole like specifics. So I didn't even know.
Comments of the most popular?
of the most popular.
Yeah, just
So this is what I personally do, and I'm a little bit obsessive about this. So I don't know. I haven't heard anybody else that does this, but I actually would go read what people are talking about and make popular libraries. Because we're actually like it's really these libraries are incredibly high profile.
Like the ones that you had in the list.
There are people kind of around the world who are incredibly invested in what these people are doing. I'll give you very some particular.
Can I take a picture of that? That's
Yeah, I mean, I'll share the.
And then it's gonna bring. But there's kind of an interesting thing that
because I couldn't get like the whole list. But yeah, so go to these, like on GitHub, find them. What is this?
This is.
Because I looked it up and it just showed prime intellect environments.
Yeah, that's it.
That's it? Okay.
Yeah, this company, they have a bunch of libraries, open source libraries.
And they're all for like different environments, basically.
Yeah, this would be something that would be a little bit more advanced, I would say. Or not advanced, but you're going to need your own tools. But for sure, this is a great, they're doing great work. But yeah, they're like,
So you would go to issues or?
I do this all the time. Like, I literally look at like, I look through what are the most recent events. I mean, TRL is a better example of it's more active. Like I was doing this today, where I look at, like some of these things are way more nerdy, but this is an example. So this is like basically a implementation that you implemented of a technique to reduce the requirements for memory utilization. And so I kind of like look at what people are talking about. This one, nobody's talking about it, but even looking at the code and seeing like that this is worth trying out. I do that a lot, and obviously like issues as well are very good for like if you see an active issue with a lot of comments that you might like here, what are important metrics that help gauge accuracy in training? Like this is amazing.
There's a discussion on it and people have talked about it.
Yeah, I mean like this is really high quality conversation with people who really know what they're talking about. So yeah, it's like
Honestly, sort of like building some sort of quick ChatGPT like interface, but it does agentic search on these kind of products and then finds info would be a cool side project.
and you can train so like so there's like search R1. I mean this is a RL library that basically it helps you very quickly get to the agent that is creating the course because you have this environment already, like you can develop something very quickly. So that's the really exciting thing about some of these environments. Like task environments is that you can go from 0 to 1 really fast.
Very interesting. I was also curious about your take on agents stock, basically.
Is that like
yeah. Is that where you're going? Yeah.
the model actually the agent is the model that they were creating. That kind of was created for you. So that's why what are the best agents?
That probably will work. I don't think you need
Why are they so good?
I have a couple
the context, I was actually that's more than 2 people. Some of the people that plot code as a best design programmatic, and I'm just wondering, like, does this use for large model, typically
So it's the agent engineering side, which is mostly figuring out the context to provide and creating your system around that. That's like completely separate. But there's another vector that can be optimized with the model itself to make like your results much better.
it's not to say that obviously it's useful, but I really when you look at like
So I mean, really want to know.
I think that one of the main reasons people are working on cloud problems is like they could add in context to like there's one thing, but really if you can train the model in an environment where it has access to do something how certain way to write code, and if you are developing a reward function that says, I think this person my product is a chatbot for I'm training a model behind the scenes that whether or not my workings are coming back. I can also, actually, what I'll do that anyways. The 5 wrappers is going to have much worse results than the model that's trained in that environment. They're all massive. Other than words that are coming from actual product data. So then you don't listen so much about the data agent. But more focused on how do I get the rewards from my product on my data.
And the value you accrue is also something different. Most companies will try to create value from just the software layer, but you can create value in the model layer. And like your product becomes very difficult to rip out.
And it becomes defensive. Like now you aren't just another wrapper. Like you're actually, you have a value. You have something that's unique to your business that no one can easily replicate. And it becomes harder and harder to replicate over time. Because you are having this constant stream of data from users that you're going to be able to bring this model on.
That makes sense.
I'm going to tour around and see if anybody can use this.
Yeah, thank you.
no, here's why it's